So the last thing we look at in our properties of function section is the idea of average rate of change. So I've drawn the picture that you see on the handout here on the board, but I want to backtrack for a minute. This is a non-linear function. It means it's not a line. It's a non-linear function. It is still a function because it passes that vertical line test. Each input has one output. If we were looking at a linear function, this is just over here a scratch work kind of thing. Here's a linear function. We could talk about its rate of change. Its rate of change would be its slope. What's its up and over, up and over. So the rate of change for a line is the slope. We know that the slope, which is m, is the change in y over the change in x. So a long time ago, you learned that as y2 minus y1 over x2 minus x1. So if we pick a point and another point, and we figure out how far up and how far over. That's pretty easy if it's a linear function. However, for non-linear functions such as curves, the rate of change isn't constant. So in other words, how I go from here to here is going to change on how I move from here to here. But to aid in study, we use a related concept called the average rate of change. What we're going to do is we're going to give the slope of a secant line through 2 points on the graph. So I've got a specific 2 points that we're going to look at. As an example 4, it asks us to use the graph to find the average rate of change from -6 to 2. So I have -6 up, finding the marker again, trying to go to blue. So we have over here, we've got a point at -6, is y coordinate is -7. It's asking us to go to 2, which is the point 2, 4. So we're going from an x value of -6 to an x value of 2. And sure enough, there is a line, that's really bad, a line that's going to connect those points. And that line is called the secant line. So a secant line simply connects 2 points on a curve, and it's any 2 points on a curve. So if you stop and think about it, if I were to come in and pick a different 2 points, then that secant line is going to look very different. If I pick a point here and a point here, it's going to be more flat. I could pick a point here and a point here, and it's going to even be decreasing. So it's a constantly changing average rate of change. So we have to give you the x values to solidify what secant line we're looking at. So for this particular one, if we want to come in and find the slope of the secant line, we're going to come in and use that formula. So that slope would be y2, which is 4, minus y1, which is a -7, all over x2, which is 2, minus x1, which is a -6. So 4 minus a -7 gives me 11. 2 minus a -6 gives me 8. So the average rate of change of this non-linear function of the curve, as you travel from an x value of -6 to an x value of 2, oops, average rate of change, sorry. Talking and not writing sometimes just does not work. Would be 11. So that leads us to a formula for the average rate of change. So if A and B, where A and B are not equal to each other, are in the function, in the domain of the function, so they exist on that function, y equals f of x, the average rate of change from A to B is defined as, and I'll use ARC to abbreviate average rate of change. It's just easier for all of us. Again, it's the change in y over the change in x, which would be f of b minus f of a all over b minus a, where a and b can't be equal because then we can define it by 0. So if I give you a function and I give you 2 input values, you can find the average rate of change for that function without having to graph it. So our final example, this is example 5, asks us to find the average rate of change of f of x is equal to -2x squared plus 4. And we're going to do several of these. We're going to go from 0 to -2. So I'm giving you 2 x values on this curve, and I want to know if I connect them, what does the secant line look like? Well, the problem is I just gave you the x values. You need the output also. We need the y values. So we're going to plug each of these, as this says, into the function. It doesn't matter what order you do it. So I'm going to do f of 0 first. So f of 0 would be -2 times 0 squared plus 4. So 0 squared is 0 times -2 is 0. I'm just going to get 4. And then we're going to plug in f of -2. So that would be -2 times a -2 squared plus 4. And again, watch your order of operations. Negative 2 squared is 4. So negative 2 times 4 and then plus 4. That's a negative 8 plus 4, which gives me negative 4. So f of negative 2 is negative 4. So we now have 2 points. One of the point is 0, 4. The other point is negative 2, negative 4. And now that I have that, I can go directly into that average rate of change. So the average rate of change, I'm going to do the change in y, so negative 4 minus 4. All over the change in x, negative 2 minus 0. This one works out really nice. We get a negative 8 over a negative 2, which is 4. It's simply telling me to move from this point to this point. I'm going up 4 and over 1. Nice and slick. Watch out. There's lots of places to make little arithmetic errors, so be careful. Okay, part B, same function, but now we're going to go from 1 to 4. So f of 1, and then we're going to go f of 4. So f of 1 would be negative 2 times 1 squared plus 4. So that's a negative 2. 1 squared is 1 times negative 2 is negative 2. Plus 4 gives me 2. F of 4 is a negative 2 times 4 squared plus 4. Again, be careful. That's negative 2 times 16 plus 4. That's negative 32 plus 4, which is a negative 28. So fairly large, right? So if we were graphing it positive 4, we're way down. Okay, so then our average rate of change, let's see if I can save myself some room here. The average rate of change in y's, so negative 28 minus the 2. So that's f of b minus f of a, or y2 minus y1, all over b, which was 4, and a, which is 1, or x2 minus x1. It's your call. So it's a negative 30 over 3, so that's a negative 10. So now you'll notice that our average rate of change is decreasing. Not good if it's profits, right? So a decreasing rate of change. Part C asks us to go from 1 to 3. So f of 1 we already found. We did it over here. We know it's 2. F of 3 we haven't found yet. So that would be a negative 2 times 3 squared plus 4. That's a negative 2 times 9 plus 1. Negative 18 plus 4. Negative 14. So our average rate of change is going to be a negative 14. Whoops. Minus the 2. All over 3 minus 1. So again, y2, y1, x2, x1. That's a negative 16 over a positive 2, which is a negative 8. So look at this. If I only went from 1 to 3 on my graph, I'm decreasing by negative 8, going down 8 over 1. But if I bump it out one more unit on the axis, all of a sudden it's much steeper in terms of decreasing at negative 10. And those are all the properties of functions we need to be able to deal with. So increasing and decreasing constant intervals, local maximums, local minimums, and then the average rate of change. So there's quite a lot of meat in this section, but in terms of lecture, it looks fairly short.